All right, so lesson 2.2. Today we're focusing on common factoring. All right, so in the previous lesson we focused on expanding. So if we look at this picture on the right hand side here, on 2.1 we focused on expanding. And what we were going for in 2.1 was we were moving from factored form, which is what you see on the left hand side of the equal sign here, and we expanded it, all right, following the red arrow to get to standard form. This, what you see, 8x squared minus 12x, this is in standard form. I know it looks different because you don't have the backside, but really there's a plus 0 there. But so that is standard form. Today's lesson is we're following the blue arrow. So we're kind of like undoing what we did last time, all right? We are factoring. So to go from standard form to factored form, you factor. And specifically, today's lesson talks about common factoring, all right? So the main concept with common factoring is we're looking for something called the greatest common factor, all right? And what that is we're looking for the biggest number that we can take, biggest number and variable, okay, so it could be both, that we can take out of each term, all right, in an expression. So let's do example 1a. When we look at example 1a, we are looking at the numbers, so in this case the 8 and the 16. Here we have two terms, right? And then we look at the variables. So here we have an x, but there's nothing here. So when you go to factor, all right, so in this case, you want to look at pulling out the biggest thing that is common from both terms. Well, if I'm looking at this two-term expression here, the thing that is common are the ones that are underlined in purple, all right? There's two purple lines, there's purple in both terms. What is the biggest thing, the biggest number in this case, because those are numbers that are underlined in purple, that I can pull out from each term? All right? And when I say pulling out, it means what is my biggest multiple that I can pull out? Well, if you think about the multiples of 8, all right, 8's multiples are 1, 2, 4, and 8. And if you do the same thing for 16, 16's multiples are 1, 2, 4, 8, and 16. So then you want to look, okay, well, what is the biggest number that is common? So you look this direction, and you stop when you see you get the same common number. So in this case, 8. So that means 8 is the biggest number that is common between both of them. And so when you factor, all right, the math is you're really saying, or what you're really doing is you're dividing all of the terms by the GCF. So in this case, the GCF, we've already identified it. Actually, we'll do that in the next step. But in this case, example 2 is actually doing the division. So in this case, we're really just looking for the GCF in example 1. So in this case, the GCF is 8. That's the biggest thing that we could pull out of there, because this one, there is no x here. So we can't pull an x out. Let's look at example B. All right, so go through the common. You can underline. So here's our numbers. All right. I see that I have a y and a y here. And then there's an x here, but there's no x on the other side. So in this case, when we look at our greatest common factoring, oh no, actually, to make this more visual, let's show this was under purple. Okay. So when we're looking for our greatest common factor, our GCF, we need to have something from the purple and something from the yellow, right? Because those are the common things from both terms. So when we're looking at the purples, which are the numbers, All right, you're looking for the greatest common factor. When you do your numbers, just think about your multiples again. So listing out 4's multiples, they're 1, 2, and 4. And then 2's multiples are just 1 and 2. Well, here is the GCF for the numbers. So 2. Well, how many y's? Like, let's look at the yellow. Well, this right here, when you have y squared, that is really like saying y times y, correct? Well, that means there are 2 y's, all right, in layman's terms. Here, there's only 1, 2. 1, I don't want you to confuse with this being a multiple. 1 y. Well, what is the biggest amount of y's that I can pull out of both terms, all right? You can't pull out more than something has. You can only pull out what it has. So in this case, we can only remove one of the y's, all right? So the GCF here is 2y. And that's it, because you can't pull out a squared. This one does not have 2 y's. It only has 1. Right. So this one looks really complicated, but the process is the same. Just look at your numbers. Okay, so the numbers I'm putting under purple. Then we go to the next one. We will do all our x's in green, green, green. And we'll do the r's in gold, gold, gold. So let's look at first the purples. Let's do the numbers the same way we've been doing it. So we're looking at 9. What are 9's multiples? And you'll get faster with practice. Right? You don't have to do this multiple chart every time. But I'm just doing it to show you, all right, if you're not very quick at seeing what the multiples are. So 9's multiples are 1, 3, and 9. Do the same for 27. 27's multiples are 1, 3, 9, 27. Sorry, I also had to check there. And then we have 6. 6's multiples are 1, 2, 3, and 6. So you look to find the common number between all of those numbers. So in this case right here, the one that I see that's common amongst all three of them, the most common and biggest number is this 3 here. So when we're writing our GCF, our greatest common factor, identifying it, well, the greatest common factor in purple is the 3, right? We can pull a 3. That's the biggest number that we can pull out from all 3 of those numbers. And then look at the x's, all right? So again, technically, this is showing you that you have 3 x's. This right here is 2 x's. This right here is also 2 x's. Oh, sorry, x's. So what is the most that you can pull out? Remember, you can't pull out more than what something has. Okay, so you look for really the smallest amount of variables. So in that case, the max we can pull out is 2, because these would run out if you pulled out any more x's. So we can pull out a x squared. You can pull out 2 of those x's. And do the same thing for r. Well, if we look at the first one, here there's 4 of them, here there's 3 of them, and here there's 2 of them. So the smallest number is the 2, right? There's only 2 r's in this term right here. So that's the most we can pull out, or else we'd run out of r's in that one. So then it's r squared. So again, you don't have to do those colors. So really your GCF, just to write it, would be 3x squared, r squared. That's what the GCF would look like. That's what you'd be factoring out. All right, big picture again is we're finding the GCF because that's the first step to factoring, all right? Which we will then factor in this part right here. All right, let's keep going. This one, way more complicated, right? Not really, but it looks more complicated. In this case right here, you have to visualize this bracket right here. This bracket as kind of like its own term or own thing, right? Like, I'm going to do something fancy here, but just so you can kind of visualize it, imagine, because there's that common bracket in both things, imagine I said that bracket, that y minus 2 bracket, I'm going to call that something, right? I'm going to call it, I don't know, a variable we don't use often, like b. So this first term right here would be 5y, and instead of writing that bracket, y minus 2, well, that's the same thing as me saying b, right? Because I'm telling you that y minus 2 is b. I'm just saying, let's just call it that, right? Haven't changed anything. And this would be minus 3b. All right. That looks a lot nicer to look at. It's easier to see. Now when we look at the two terms, look for your GCF. Well, in this case right here, the number 5 and 3, well, there is no common multiple from 5 and 3, right? There's nothing that you can pull out of them. Well, here, this y, there is no y on the second one. And this is why I put those brackets, all right? Well, here you can see that there is a b, which was those brackets, that is common. So in this case, our GCF is, that b term is b. But b is something we made up, okay? In reality, our GCF is actually that y minus 2 bracket. So we're going to pull eventually a y minus 2 bracket out of each term. Let's do it without doing that change of variable, okay? So can you see how you have this bracket here and you have the same bracket right here? Here, there's a number, technically that's 1 times a bracket. Here, there's the number 4. Well, in terms of the numbers, we can't pull anything out. This is already having a value of 1. Like, you can't, that's the smallest you can get. So the things we've underlined in red, can't do anything with those. But in terms of the ones we've underlined in green, well, you can see that both of those terms have that bracket underlined in green. But remember, this first bracket we're writing here, technically, because it's squared, there are 2 of them. There are 2 of these brackets, minus that 4. And in the second term, there's only 1 of these brackets. So just like when you take out a variable, you can't pull out more than what something has. So our GCF is just, this one has 2 of these brackets, and this one has only 1 of those brackets, where a GCF, the max we can pull out is 1 of those brackets. That's what we're going to be able to factor out. So now, in example 2, we are going to use the GCF that we've identified in the previous example. So in this case right here, example A, our GCF was 8. And I'm just copying them from the previous question. Here we've identified the GCF. Actually, you know what? I'll put a different color so it's easier to see. The GCF from the previous example was 8. Here the GCF, the greatest common factor, was 2y in B. Here the GCF was 3x squared, r squared. In D, the GCF, looking up above, was just y minus 2. And then here, the GCF on E, the one we just did, was 3x minus 2. All right. So now, now, the purpose of identifying the GCF, I was going to say this before and I forgot, like this is when we're actually doing the factoring, okay? So now we are actually factoring, okay? And what the factoring is you are dividing out each term by the GCF. So when you divide out, you are dividing this term by 8, 8 being our GCF, and you're dividing this term by that 8. And as you read here, once you've done the division, the GCF goes on the outside of the bracket you create. So you can't just get rid of it, right? Mathematically, you can't just divide something by 8. Right? So now you've changed it. The 8 doesn't go anywhere. But what happens is that factor goes on the outside of the bracket. So 8 is the GCF. So that's where that GCF is. That's our GCF. All right. Well, what goes on the inside of the bracket is the result of doing this division right here. So let's look at the first one. What is 8x divided by 8? Well, doing that division, this 8 and this 8 cancel. And you're just left with x. Well, what is 16 divided by 8? 2. And there you go. That's the answer. If you were to undo this, okay? So if we were to check, and when I say undo, right, here was standard form. Here is factored form. So if I want to undo and check to see if my math is correct, what I'm going to do is I'm going to expand, right? Remember, to go from factored back to standard, or undoing what we've done, is we're going to expand it. So our answer, I'll do it in purple just so you know that like we're done with the problem, but we're just going to check. So our answer was this, 8x plus 2. Well, if we want to expand, remember you go 8 times that x, so here you would get 8x, and then that 8 times that 2, that would give you plus 16. And that's exactly what we had. That's exactly what we started with. Get rid of this, all these cross off here, right? Look up top. That's the exact expression. That's the same thing you started with. 8x plus 16, 8x plus 16. So that means this was the correct factored form. Right? You don't need to do this check every time. I just wanted to show you that the process that we did was correct, okay? When we divided each of these by 8 and you put that GCF out front there. So let's do it again for this time. All right? So when we factor out the GCF, remember, your GCF goes in front here. I should give myself some more room. When you're factoring out, the GCF goes in front. All right? And then these two terms, when they're divided by 2y, what is left? And whatever is left, that's what goes inside the bracket there. So let's look at the first one. 4xy squared, all right, divided by 2y. Well, the numbers divided by the numbers, so how many times can 2 go into 4? Or technically this 2 and this 4 cancel, and you're left with, I'll do it in red, 2, right? So that's 2. This y and one of these y's cancel, so you're just left with y, and nothing happens with the x. So you're left with 2x y. here, the 2 and the 2 cancel, and the y cancel. But careful. When I say the word cancel, it's not like they go to 0. Mathematically, what actually happens is when you're doing a division is 2 divided by 2 equals 1, not 0. So don't put plus 0 here. That's not the case. Mathematically, what you're saying is how many times can 2y go into 2y? Well, it can go in 1 time. So 2y, factoring out 2y, simplifies to becoming 1. Let's get rid of our colors, right? And this is your final answer. 2xy plus 1. And if you want, you can check. You can expand that back out and see if you get the same answer you started with. Oh, sorry, I didn't put a bracket here. Okay. So, again, what are we doing? We are factoring out our GCF. Let's move this over here and I'll make it smaller, just so it's not confusing. All right, so we have our expression. You write your GCF, y minus 2. And because there's already so many brackets, I'm going to use a fancy square bracket. It's the same thing as a round bracket. It just makes it easier to visualize. So now, do the same process. Take each of these terms. So this is one big term right here, because technically this is being multiplied right here, right? So you take that one big term and you divide it by the GCF. So our GCF was y minus 2. Well, up top here, you can see I have 1y minus 2. There's technically a 1. There's one of these. And I'm dividing it by 1 on the bottom. So these cancel, right? And again, saying cancel really means they're turning into 1. And then that 1 times that 5y just leaves you with 5y. You're taking this term and you're factoring out the GCF, y minus 2. And again, this cancels and this cancels, or turns into 1. So then what is negative 3 times 1 multiplied by that 1? Well, you're just left with minus 3. And there you go. And let's just rewrite it into a nicer way to look at. Y minus 2, the GCF, multiplied, there's a multiplying right here, by the second bracket, 5y minus 3. Again, this square bracket right here and this round bracket right here, same thing. Do not change anything. They're the same math, okay? Last one. In this case, our GCF is 3x minus 2. So we have our GCF being 3x minus 2. All right, I'm going to use those square brackets again. I'm dividing the first term by the GCF, 3x minus 2, and I'm dividing the second term by the GCF, 3x minus 2. Well, if I look at the first one, I see that I have 2 of these 3x minus 2's. So I will cancel and I will get rid of, and they'll be left with just 1. So they'll just be left with 1 3x minus 2. And then if we look at the second term, well, this one has an exponent 1 up there technically. Well, if I'm taking away one of those 3x minus 2's, well, then that cancels, and you're just left with minus 4. So careful, this is not your final answer, because technically these brackets, these ones right here, I can get rid of them, right? Because there's nothing to simplify inside of this bracket. So what I'm left with is still this greatest common factor on the outside. And then if I get rid of those blue brackets there, this is 3x minus 2 minus 4. Well, collect these like terms right here. So that becomes, and now let's just write it like that, all the colors, 3x minus 2. And then that square bracket becomes 3x minus 6. And then there is your final answer, okay? So this is factored form. All right, once again, star any questions you have trouble with understanding, and we can take them up in class. Oh, sorry, we actually have one more problem. I apologize. A triangle has an area 12x squared plus 48x and a height of 3x. What is the length of its base? Oof. All right. Well, let's draw a picture. Picture's worth 1,000 words. All right. So we're dealing with a triangle. There's the first thing. What does a triangle look like? Well, we got 3 vertices. Vertices. Is it C's or says? I don't know. Vertices. There we go. It has an area of 12x squared plus 48. Okay, so we'll deal with that in a second. And a height of 3x. What is the length of its base? All right, so it's telling us that we have a height of 3x. Well, the height is this, the height of your triangle, right? That is 3x. So what the question's asking for is, what is the length of its base? So the base is right here. Right, this is the base. I want that dimension right there. All right, so let's call that B. And let's call this H, because it's the height and that is the base. Well, recall that the area of a triangle is base. Actually, I'll put it in red because base times height divided by 2. All right, well, let's fill in what we know so far. So we were given an expression for the area of a triangle. I said we'd come back to this after. The area of the triangle is this 12x squared plus 48. This right there is what the expression is equal to. That's what this base times height divided by 2 is equal to. So this is 12x squared plus 48x. The base, well, we don't know. That's what we're looking for. We're looking for this thing in red. And then it gave us the height. The height is 3x divided by 2. So let's rearrange this expression and solve for the base. So rearranging this expression, we need to follow the rules of SAMDEB, okay? SAMDEB. So we need to get rid of this 2 first on the bottom. So we multiply both sides by 2. Both sides of the expression by 2. All right? So this whole expression, just like a distributive property, 2 times 12x squared, well, that becomes 24x squared. And then 2 times 48, well, that is plus 96x equals, and now we got rid of that 2 on the bottom. This 2 and this cancels. And you're left with base times 3x. Again, we're looking for base, so I want b equals. So I need to, my next step is I need to get rid of this 3x. So that is a multiplication here. So I'm going to divide it out. So these will cancel. And then I need to divide this whole thing, right? Whatever you do to one side, you have to do the other, by 3x. So careful here. When you are dividing 2 terms up top, right? This is 2 terms. by something on the bottom, this is the same thing as you saying 24x squared and just dividing each term individually by 3x plus 96x. You can just split it. That's like a common denominator that you're just splitting. And then you'd be equals base. Oh, sorry, red. Base. So dividing your variables, well, what is 24 divided by 3? Well, this 3 and this 24 will cancel, and you'll be just left with 8. So you have 8. This x and one of these x's will cancel, so you have 8x plus 96 divided by 3. So 96 divided by 3 is 32. So there's 32. So 32. And then both of these x's will cancel. And that is what's equal to B. There is your final answer. B equals, or we can just, so therefore, B equals 8x plus 32. That is in standard form. Did the question ask for factored? What is the length of the base? No. But let's say if it did, all right? If I wanted to put this into factored form, because this whole lesson's been on factored form, well, you'd have B, look for your GCF here, so 8 and 32. What is the biggest number that you can pull out? Well, I can factor out an 8 from both of those. So factoring out an 8 would be 8 in front, that's a GCF that we identified, and then that 8x, right? When you factor it out, that'd be like dividing both of these by 8. You'd be left with just x plus 4, and that is factored form. And now we are done. Okay, awesome.